Today, we're taking a journey to the absolute limits of temperature. We're going to explore a state of matter so bizarre and so fascinating, it was predicted almost a century ago, but only created in our lifetime. So get ready to meet the coldest thing ever forged by humanity.
So, let me just ask you a question. When you think of the coldest place possible, what comes to mind? You're probably picturing the freezing vacuum of deep space, right? But what if the coldest spot in the entire known universe wasn't out there among the stars at all?
Yeah, you heard that right. The record for the coldest temperature ever achieved wasn't in some distant nebula. It's right here on Earth, created inside these highly specialized labs by scientists who are pushing the absolute boundaries of what we thought was possible. This incredible achievement is really part of a century-long scientific quest, a journey to reach the ultimate floor of temperature, a point called absolute zero. So what is absolute zero? Well, at 0 Kelvin, it's the theoretical point where particles basically stop moving. They have the minimum possible energy. You can't get any colder. And as you get closer to this absolute floor, the familiar rules of physics start to get really, really weird. You see, in our everyday world, things are solid, they're separate. But when you strip away almost all the heat, almost all the energy, that solid, predictable world just dissolves. And the strange, probabilistic rules of the quantum realm, they start to take over, completely dominating how matter itself behaves. But here's the really cool part. This bizarre quantum behavior, it wasn't a total surprise. In fact, almost 100 years ago, two of the greatest minds in physics predicted that something extraordinary would happen right at this frigid frontier. So back in 1925, you have Satyendra Nath Bose and Albert Einstein theorizing this new state of matter purely on paper. But then, look at that gap. It took 70 years of incredible technological advancement for experimental science to finally catch up and prove that they were right all along. And their prediction, it was about so much more than just getting things cold. It was this prophecy that, under these extreme conditions, the very identity of individual atoms would just dissolve. They'd start to act in perfect unison as one single giant superatom. So, how in the world did scientists finally pull off this feat of cosmic refrigeration? Well, the process is this incredible multi-stage masterpiece of engineering. First, just take a second to appreciate the temperature we're talking about. Scientists had to cool a cloud of atoms to 1/1000th of a Kelvin. That's a tiny, tiny fraction of a degree above absolute zero. It is profoundly, unimaginably cold, way, way colder than the deepest, darkest reaches of space. And the cooling process itself is just a work of art. First, they use lasers to bombard the atoms. The photons act like this thick headwind, slowing the atoms way down. Then, they trap these now much cooler atoms inside a powerful magnetic field. And the final step is brilliant. It's called evaporative cooling. It's just like how your coffee cools down as the hottest steam escapes. They let the most energetic, hottest atoms fly away, leaving only the ultra-cold ones behind.
Okay, so after all that cooling and all that trapping, what actually happens? When those atoms reach that final, frigid state, what does this new form of matter, this fifth state, even look like?
This is it, the Bose-Einstein Condensate, or BEC. It's officially the fifth state of matter. You see, in the quantum world, every particle also acts like a wave. In a BEC, the individual waves of thousands of atoms start to overlap and merge until they become completely indistinguishable, behaving as one single coherent matter wave. Let's think of it this way. A normal gas is like a stadium full of people all shouting randomly. It's just a chaotic crowd. A Bose-Einstein condensate, on the other hand, is like that entire crowd suddenly starts singing the exact same note in perfect, flawless unison. It's a single, coherent choir. The individuals have literally merged into a collective whole. And this collective state has some truly mind-bending properties. For one, BECs can flow without any friction at all. It's called superfluidity. If you could somehow stir one, it wouldn't swirl around randomly like water. No, instead, it forms these tiny, perfect little whirlpools called quantized vortices. It is literally the quantum world blown up to a scale we can actually see. Okay, so this is all incredibly cool, but is it just a scientific curiosity? Absolutely not. The ability to engineer quantum behavior on a scale we can actually see and control, well, that has profound implications for the technology of our future.
People are already exploring the properties of BECs for some unbelievable new technologies. We're talking about things like atom lasers that can paint circuits with matter instead of light, ultra-precise atomic clocks because every single atom in the condensate ticks in perfect unison, and even powerful new tools to simulate complex quantum systems or hunt for gravitational waves.
So, what's the big takeaway here? Well, Bose Einstein Condensates act like a magnifying glass for the quantum realm. They let us directly observe and manipulate quantum phenomena that are normally totally hidden from our view. It's like they've given us a powerful new window into the fundamental fabric of reality itself. And that leaves us with a really fascinating thought. For decades, the quantum world has been this source of mystery and immense potential. Now that we can actually build matter in this fundamental state, from the ground up, are we on the verge of finally mastering it? This superatom might just be the key.